Okay, I wanted to finish up section 6.4 now. In the previous video, we looked at the graphs of the sine function, y equals sine x, here was that, and then also y equal cosine x. Sine x is really just taking the cosine curve and then shifting it to the right, pi over 2 radians. Okay. There's a couple of problems in this section here asking you for the amplitude and the period of the function. So the amplitude of a periodic function is half the difference between the largest possible value and the smallest possible value. So like if I had y equals sine x, which we've seen that graph, the highest point is at a height of 1. The lowest point is at a height of -1. So the distance from the highest to the lowest points would be a distance of 2 units. Okay. Now I want half of that distance. Therefore, the amplitude of the sine curve would be 1. If I had y equal 2 cosine x, that would be a vertical stretch of the cosine curve by a factor of 2. And so the distance from the highest to the lowest point would be a distance of 4. Therefore, the amplitude would be 2, since it'd be half that distance. If you had y equal 5 sine x, the distance from the highest to the lowest point would be a distance of 10. Half that distance would give us an amplitude of 5. Now, in the definition, sorry, if we look at the next example here, y equal -3 cosine x, the amplitude is 3. Now, I'm not saying -3, okay, because in the definition, we're looking at the difference between the largest value and the smallest value. Okay, we're describing half that distance, and distance can't be a negative. Therefore, in general, if you have y equal a times sine x or y equal a cosine x, then the amplitude would be the absolute value of that multiplier, whatever it is in front. Okay, the point is to say that the amplitude is always going to be a positive number when you're asked that question, although you might have a negative multiplier like what we see here. Another definition, the period of a periodic function is a measure of how often the function repeats the same values. We've already talked about the fact that all 6 trig functions are periodic. In general, if omega, that's a Greek letter there, if omega is some positive number, then y equals sine of omega times x and y equal cosine of omega times x will have a period of t equals 2 pi divided by omega. So here's an example. Like if I had the equation y equals sine 4x, and they were asking to identify the period of this function, the fact that I've got a 4 there means that the period is not going to be just 2 pi radians. Okay, I'd have a horizontal shrink by a factor of 4. Now what that looks like here, using this formula, is my omega value would be 4. 2 pi divided by 4 would be pi over 2, and so the period of this function would be pi over 2. And what that would mean to us is that, if we were to look at a graph, what we see on the interval 0 to pi over 2 would repeat infinitely often, okay, since you've compressed the graph horizontally. Here's another example. If we had y equal -4 times cosine pi x, the amplitude would be 4. Again, you always want the positive of that multiplier, whatever it is. And the period would be, okay, omega is pi, so 2 pi divided by pi, the pi's cancel, we get t equal 2. So the period would be 2 radians. Okay? If we're on the interval 0 to 2, what we see there would repeat infinitely often. And here's another example. If we have y equal 2 sine of -pi over 2x, the amplitude is 2. Now the sine function is an odd function, so therefore sine of -pi over 2x, that'd be the same as negative sine of pi over 2x. I've got a 2 in front of that, of course. And that's how I'd want to look at this, because in the definition, omega is a positive number. Okay? Therefore, the period is always going to be some positive number. Okay, you're looking at how often a curve is going to repeat on an interval, and the fact that you're describing distance means that the period is never going to be a negative. Okay, so you could have a negative omega value, you could have a negative a value. The amplitude and the period will always be positive numbers. Keep that in mind. So here, omega is pi over 2. 2 pi divided by pi over 2. When you flip the denominator, the pi's will cancel. 2 times 2 is 4. So the period of this curve would be 4 radians. Okay, now there's also a couple of questions in the book, like where they'll give you a graph, and they'll want you to find the equation for the graph. Okay. In those problems, we would like to identify the period and the amplitude. And now also, one of the things that I'm doing early on is I'm identifying if the curve is related to the sine curve or the cosine curve. Okay, now you're going to know that right away by telling if the curve is going to pass through the origin or not. Okay, the graph of y equals sine x starts at 0, 0. The graph of y equal cosine x starts at 0, 1. Okay, so like in this first graph here, like I would know right away, I'm going to do something with the sine curve. Okay, now it's not going to be just y equals sine x, okay, because of the scaling that I see here. So I'm going to want to identify the period and the amplitude. The amplitude is half the distance from the highest to the lowest point. So here I've got a distance of 10 units. The amplitude therefore would be 5. And in this picture, it looks like this section here that is going from 0 to 4 pi is going to repeat infinitely often. So the period would be 4 pi radians. Now I need to identify the omega value, and if t is equal to 2 pi divided by omega, and we've identified that t is the periodic factor, that's 4 pi here. When you solve this equation for omega, 2 pi divided by 4 pi, the pi's cancel, you're going to have omega equal 1/2. So the equation of this graph that I've drawn here is y equal 5 sine of 1/2 x. On this other example, okay, I see that I'm doing something with the cosine curve, right? The curve does not pass through the origin, so I know right away I'm going to do something with the cosine curve, although it's not going to be just plain old y equal cosine x, because of the scaling here that I see is different. Now, the distance from the highest to the lowest point is a distance of 5, and so the amplitude is going to be 5/2. Now, on the graph of just y equal cosine x, 0, 1 is my only y-intercept. Notice how this graph is not starting at 0, 5/2, but 0, -5/2. So we would want to indicate here that we had a reflection about the x-axis. Therefore, -5/2 is going to be the multiplier that we'll want in front of the cosine function. The next thing that we want to do is look at the period here in this curve. It looks like what we see on the interval 0 to 2 is going to repeat infinitely often. Okay? That's one section of the cosine curve here in this graph. So the period is 2 radians. That'd be my t value. If I solve this equation for omega, omega would be pi. So y equal -5/2 times cosine pi x, that would be the equation of this graph that we have here above. Okay, and we're now done with section 6.4, so the homework problems are on page 419. Be sure to look at those.